here. Here we go. We'll see if a couple more people sign in. We're still waiting for some. So that's the first thing. The test on Wednesday next week, along with homework number 4 being due. So those two things go together. Remember, I had originally said Monday and then I pushed it back. So that's next week, Wednesday. We will start right at 9. We can't start earlier because I have a class beforehand at 8, but we can plan to go longer. So it's going to take you a little bit of extra time to take pictures of your test and upload it to Moodle and all that fun stuff. So we will plan to go longer. If you have issues with that, I don't think anybody does because normally chapel would be after this class, but if you have issues with that, let me know and we will work something else out. Okay, and we'll talk about logistics of that at the end of class once we get everybody who's going to sign it. That's my first thing. Everybody good there? Okay, all right. Secondly, then homework is due on Wednesday. Are there any questions on homework at this point in time? Anything for homework questions that people have? I've been getting some emails, which is great. I'm more than happy to reply to those as well. Anything for homework questions? No, good. Okay, then here's the plan for today, and we'll see if we finish all of this or else we might need to spill over a little bit into Monday, but I'm not super concerned about that. We've got one more primality test to talk about. So we've talked about Fermat's primality test, and we've talked about the Miller-Rabin primality test, right? Those are the ones that we've discussed so far. The one other one we want to talk about is called the Solovay-Strawson primality test. And this is on the same slide, so that's why there's no new slides on Moodle. They're the same as last time. What I need to do first is talk about this new mathematical symbol. It's called Jacobi symbol. So this is something that gets used in the Solovay-Strawson primality test, and I can't see you anymore, so if you have questions, you're going to have to do a virtual hand raise. So let's talk about the Jacobi symbol. It's also called the Legendre symbol. A little bit of both, but here's this new mathematical concept. So it's called the Jacobi symbol. That's a J, sorry. So the Jacobi symbol has 4 basic rules. Well, actually, let's talk input-output first. Sorry. So my input is 2 integers. We'll say M and N. And my output is 0, 1, or -1. So my input is 2 integers, M and N. My output is 0, 1, or -1. The notation for this is M divided by N, except that's not really division, and we're gonna put it in parentheses. So that's my notation for the Jacobi symbol. You just read that as the Jacobi symbol of M and N. That's the way it gets read. And here are your rules for evaluating. So 4 of these. Rules for evaluation. First of all, if you have a Jacobi symbol, you can reduce the numerator mod the denominator. So you can say M mod N divided by N. If you have the Jacobi symbol, you can reduce the numerator mod the denominator. So you can say M mod N over N, that Jacobi symbol. You can do a substitution. Secondly, the Jacobi symbol of 2 over N is equal to 1 if N is congruent to positive or -1 mod 8. So this is a piecewise function. Jacobi symbol of 2 over N is 1 if N is congruent to positive or -1 mod 8. It's -1 if N is congruent to positive or -3 mod 8. So -1 if N is congruent to positive or -3 mod 8. There's a bunch of values that we haven't talked about, right? Like if n is congruent to 2, 4, 6, or 0 mod 8, that will come up in rule number 5. And I told you there were 4 rules for evaluation. I lied to you, there are 5. Number 3, if you are multiplying, so u times v over n, you can split apart. So you can say this is u over n times v over n. So if you're multiplying, you can split into 2 separate Jacobi symbols. The Jacobi symbol preserves multiplication in the numerator. You can split into 2 separate ones. Number 4 is probably the most important one for evaluating. If you want to evaluate the Jacobi symbol of m over n, and this is if m is less than n. This is a piecewise function. It's a little complicated. It is the reciprocal, so negative n over m, if 2 things happen. M is congruent to 3 mod 4, and n is congruent to 3 mod 4. So if both m and n are congruent to 3 mod 4, then when you flip, you put a negative outside. If one of those is not congruent to 3 mod 4, then you can just flip. So you can say just n over m and not worry about a negative. So that one is helping you flip. It'll help you to always get the bigger number from the top to the bottom or vice versa. And then you put a negative out in front. And then last, 5th one, Jacobi symbol of m over n is 0 if the GCD of m and n is bigger than 1. So the Jacobi symbol is 0 if the GCD of m and n is bigger than 1. If m and n are not relatively prime, then your Jacobi symbol is equal to 0. This helps us out with rule number 2, right? Because if n is congruent to 2, 4, 6, or 8, 2, 4, 6, or 0 mod 8, then 2 and n are not relatively prime. So the Jacobi symbol is equal to 0. So rule number 2 and rule number 5 kind of go together. Okay, I want to run through one example of how to actually evaluate this. And then we're going to say, yeah, we're never doing this by hand again, and how can we use it in a primality test? But it would be good to know how to do it by hand at least once, because we are math people, some of us are computer scientists, and those of you can be thinking about how you would write a program to do this instead of doing it by hand. But we're going to do it by hand once, and then we'll talk about how this comes in the primality test. Okay, so for example, let's say we want to evaluate the Jacobi symbol of 66 over 175. And I'm sorry, this is where things are unfortunate. I don't have my rules on the previous slide. And if I were teaching on chalkboard, we would have lots of space and they would still be up there, but they've gone away. I'm sorry. So first off, I am going to use rule number 2 to, nope, let's try rule number 3. I can't read my own handwriting. If I use rule number 3, I can factor out a power of 2 in the denominator. So I can do 2 over 175 times 33 over 175. So that's rule number 3. I can do some factoring, right? 2 over 175 and 33 over 175. I can evaluate that 2 over 175. So if you do 175 congruent to something, mod 8, do that quick. 175 congruent to what mod 8? 275. Do that quick, should be congruent to 7 mod 8, and that isn't the way we're writing it for the Jacobi symbol. We want to do -1. So 7 and -1 are the same thing, and therefore, if I use rule number 2, label that on the bottom. If I use rule number 2, that first one, turns into a positive 1. So this is 1 times the Jacobi symbol of 33 over 175. That's rule number 2. I can get rid of the 2. At this point, I have a couple of choices. I could do this 2 ways. Either I could split up the 33 as 3 times 11 and use rule number 3 again. So I could totally do that if I wanted to. Or I could flip and then do some reducing with mods. I'm gonna flip using rule number 4 and do some reducing with mods, but you could also pull this apart into 2 pieces if you wanted to. You can do it either way. So we need to check some mods because we want to use rule number 4 here. So if we do 33, that's congruent to 1 mod 8. That's an easy one. Oh, I'm sorry, I want to do mod 4. I'm sorry, let's do mod 4. Same answer. 33 is congruent to 1 mod 4. We're doing mod 4 because we're working with rule number 4. And that means I'm in the otherwise category. I don't even have to check what 175 is congruent to. So I can just flip this without putting a negative out in front. So we can do Jacobi symbol of 175 over 33. So we can just flip. Okay. Rule number 1 is going to help us make that denominator or the numerator smaller. So if we do 175 congruent to what? Mod 33. Take just a minute, do that congruence. Also 175 is congruent to what? Mod 33. Take a sec, do that congruence for me. 175 congruent to what mod 33?
10.
I got a 10. 10 is good. I like 10. So using rule number 1, I can flip, or I can do a mod, sorry, and we can say this is the Jacobi symbol of 10 over 33. Got an even number, so I can pull out a 2 now. So let's do this in 2 steps instead of writing it out separately. So we can use rule number 3, and we can use rule number 2. And what we need to check is 33 congruent to what? Mod 8. This goes with rule number 2. Since I'm going to have a 2, 33 is congruent to 1 mod 8. And so therefore this is just 1 times the Jacobi symbol of 5 over 33. 1 times the Jacobi symbol of 5 over 33. Okay. Finishing, we got 1, 2, 3 more steps. I already have that 33 is congruent to 1 mod 4. So I can flip without a negative, and we can also do that 33 is congruent to 3 mod 5. I'm combining some steps here. So I'm going to combine step number 4 and step number 1 to get 3 over 5. Jacobi symbol of 3 over 5. Because 33 is congruent to 1 mod 4, I can flip without doing a negative, and then I can reduce the top mod the bottom. So I can flip without doing a negative, and I can reduce the top mod the bottom. Flip without doing a negative and reduce the top mod the bottom. Okay, 2 more steps. I'm going to do the same thing. So 5 is congruent to 1 mod 4. That means I can flip without doing a negative. 5 is congruent to 1 mod 4, so I can flip without doing a negative. And 5 is congruent to 2 mod 3. So I can also reduce the top mod the bottom. So we're going to get the Jacobi symbol of 2 over 3. I'm flipping without doing a negative, and then I'm reducing the top mod the bottom. So I'm flipping without doing a negative, and I'm reducing the top mod the bottom. And last, if I use rule number 2, what I need to check is that 3 is obviously congruent to 3 mod 8. So using rule number 2, this ends up equaling -1. Okay, that's how you compute the Jacobi symbol by hand. We are never, ever, ever, ever doing that again, but that's how you compute the Jacobi symbol by hand. I'm going to stop sharing my whiteboard and get everybody so that I can see all of you and have you give me a thumbs up if that makes sense. Yes, following that, and then a thumbs up that we are never, ever, ever doing this by hand again. Yeah, okay. So here's where this is going to be helpful in terms of a primality test.